Hi everyone, what I'm going to be going over today is finding area and perimeter of irregular figures, including circles within those figures, semicircles, sectors, so on and so forth. So in addition to all the area formulas that we've talked about, we are going to now include area of a circle, which is pi r squared, and also circumference of a circle, which is 2 pi r or pi d, in addition to also recalling how to find area of a sector and perimeter or circumference of a sector. So again, the two new formulas we're going to really be applying are these two up here. So for the first diagram, what we have is this figure over here, which is composed of a rectangle, a triangle, a semicircle, and another rectangle down here. So the first thing that we are asked to do is to find the area of the figure and then leave our answer in terms of pi. So to find the area of this figure, we have to find the area essentially of 1, 2, 3, 4 different shapes. So area of a rectangle here, area of a rectangle here, area of this triangle, and then area of this semicircle over here. So what I did was I outlined what I know I needed to do: area of a rectangle, area of a rectangle, area of a triangle, and area of a semicircle. And then right above it, I just jotted down all the formulas that went along with it. And then for area of the rectangle, I said, all right, well, if I know that this is 16, this is the base, and then this is the height, so I have 16 and 12 for area of a rectangle. This rectangle down here is also 16 by 12. And that actually helped me find the area of the triangle, because if this side was 16, well, then this base of the triangle is 16, and if this side of the rectangle is 12, well, then the height of this triangle is 12. Okay, so that's how I got the first three with all those substitutions. Now, to find the area of the semicircle over here, I know area of a circle is pi r squared. It's half the circle, because I could clearly see that the diameter is drawn in. So I divide my area by 2. Remember, I need to have a radius in order to find the area of a circle. So if I take a look here, this segment is blank. There's nothing there. So when I connect, I have myself a right triangle. So up here, in order to find the diameter, and then I'm going to use the diameter to get the radius, but in order to find the diameter, I'm going to use Pythagorean theorem. Okay, here's my right angle, right here, in this little corner. So that means I have a squared and b squared at 12 and 16, so a squared, b squared. And my hypotenuse is going to be the side opposite over here, and I'm just going to make that my x. So when I substitute in everything, I evaluate, and I get 400 equals x squared, take the square root, and then x is 20. So if the diameter is 20, that means when I divide it by 2, it gives me the length of the radius. So the radius length is then 10. So I substitute in that here, and then it says leave my answer in terms of pi. So I get all these values, right? I add them up, I get 480. And now this over here, your area of your semicircle, I just keep simplifying. So 10 squared is 100. 100 divided by 2 is 50. And then I bring down my pi, so 50 pi. The reason why you can't add these two numbers together is because the 480 doesn't have pi, so they're not like terms, right? Although pi is actually a number, an irrational number, it acts as a variable in terms of combining. So I can't say 480 plus 50 and then pi, right? It's 480 plus 50 pi, units squared. So that's how you find the area. The perimeter is the outside of this figure here that we have. So when I'm dealing with the perimeter, if I'm walking the perimeter of this shape, I wouldn't be dealing with this inside over here, right? We're going to kind of exclude those. So really, my perimeter, take a walk, it starts at 12, 16, 12, 16, 12, and then we get to the semicircle, so I'm going to leave that alone, and then the 16 over here. So it's all of those highlighted values. And then this semicircle, I need the perimeter of the semicircle. Remember, perimeter of a circle is the circumference. But if it's a semicircle, it's half the circumference. So I know circumference is pi times diameter. I want to take half of it, so I'm going to divide by 2. So half of 20, because the diameter is 2, is 10. So half my circumference is 10 pi. So when I find my perimeter, here it is, I add up all those values, and then I add 10 pi, and I get 84 plus 10 pi units. Now, they didn't tell us the units, but we do know that area is squared units, and perimeter are just units. Okay, so that was number 1. For number 2, we have to find the area of the shaded region. So again, it's dealing with the area of a circle, but if you take a look at what we have here, the shaded region are these little figures on the top and the bottom middle. So ask yourself, really, what do you have in this diagram? Well, we have a square, right? And it looks like we have 2 semicircles. We do have 2 semicircles. And the semicircles have diameters of the same length, because I know since this is a square, if this is 10 centimeters, so is this, and so is this side, and so is this side. So 2 semicircles make up 1 full circle. So what do I have to do here? Well, think back how to find area of the shaded region. It's area of the big figure, and then you take away what's missing. So our big figure here is a square, and what are we taking away or cutting away from the square? Our 2 semicircles, which when put together is a full circle. So here's my guide. I have area of a square minus the area of the circle. So base times height is how you find the area of a square. Area of a circle is pi r squared. We just make some substitutions. The square is 10 by 10. The radius of the circle is 5. It says to round to the nearest tenth, so I just simplified. We have 100 minus 25 pi. Put this all in your calculator, round to the nearest tenth, and we get approximately 21.5 square centimeters for number 2. Okay, and then we have number 3, the last question. So for number 3, we have this diagram, and we are told now that the area of the shaded sector is 12 pi square inches. So I know that the area here is 12 pi square inches, so I wrote that down, AOS, area sector, 12 pi. And the length of OA, which is the radius, is 6 inches, okay? We're trying to find the measure of angle AOC. So you're really looking for theta, because when you're dealing with area of a sector, it's this formula down here. We know area of a sector is the area of a circle, pi r squared, and you're accounting for the piece of the circle, theta out of 360. So of this formula, I know the area of the sector is 12. I know the radius is 6. Theta, or x, if you want to label it x, is missing. So I make all my substitutions, and this is what I have now. So my area of a sector is 12 pi, theta is missing, my radius is 6. Okay, so this is really algebra based now, right? We have to solve for x, or theta. So what do we do? All right, well, I evaluate 6 squared is 36, and then I like to simplify. 36 goes into 360 10 times, so the 36 then becomes a 1. So now I have theta over 10 times pi equals 12. Now, pi is on both sides, so essentially we could say it, quote unquote, cancels out. Remember, cancels out means it really is dividing by itself and then turning into 1. So I cancel out my pi's, and I'm left with theta over 10 equals 12, but I'm going to put 12 over 1 so that now I can cross multiply. And when I cross multiply, 10 times 12 is 120, theta times 1 is just theta. So theta represents angle AOC, which is an angle. We say angle are measured in terms of degrees. So angle AOC here is 120 degrees. Okay. Number 4, there's 2 parts, A and B. It's the same diagram. So for A, you're looking to find the area, and for B, you're looking to find the perimeter. This little sentence here basically just says that you can assume, it's good to assume here, that this shape in the middle is a rectangle, and then you have your 2 semicircles on the side. So remember what we had said earlier. 2 semicircles, when put together, if they have the same diameter, make up a full circle. So the area here, just kind of give you a little hint, we have a rectangle plus a full circle. Okay, and then the perimeter, remember, it's just along the outside. It looks like a track here. So we would have, this side, which matches this side, And then you have the two semicircles, which when put together is the full circle. So circumference of the full circle. Okay. So these two answers for 4A and 4B. You're going to leave your answer in terms of pi. It'll be multiple choice. Go ahead and submit that through Google Forms. And then finally, you have to just try out number 5. Number 5 is just like number 3. Put a little hint here. Just like number 3. So if you like, please go back and take a look at number 3. Right? Set up your area of a sector. Formula. The important information is the area of the sector here is 20 pi. The length of OB is 10. You're trying to find theta or angle AOB. Okay, so these were some practice questions. Please don't forget to go ahead and scroll down and submit your answers through Google Forms.